REST is short for Representational State Transfer. It is a software architectural style that defines a set of constraints for creating web services that can communicate with clients. Web services are basically resources that are available over the web. There are two basic types of web services: SOAP web services and RESTful web services. SOAP stands for Simple Object Access Protocol. The SOAP way of building web services is the older approach. It uses WSDL, the Web Services Description Language, for specifying how two endpoints in a network communicate with each other. SOAP typically depends on XML for its messaging format, whereas REST is more flexible. REST can use XML, HTML, plain text, or JSON, usually JSON. Web services built using SOAP were the de facto standard at one point, but REST has overtaken it in popularity. The REST approach is simpler and easier to implement. However, note that where SOAP is a protocol with strictly defined rules, REST is not. REST describes an approach, but it does not lay out exact specifications. There are 6 defining constraints of REST. Web services that conform to these constraints are called RESTful. I'll go over each of these briefly, but be aware that this will not be an exhaustive explanation of these constraints, and you are welcome to explore the REST constraints further on your own. 1. Client-server separation. The client and server can be implemented separately from each other as long as the interface between them stays consistent so they can still communicate. This division of UI concerns and data storage concerns improves the flexibility and scalability of both sides, and they're able to evolve independently of each other. 2. Statelessness. This means that the server does not store any information about the client's state after the communication is complete. So a server receives a request and it responds, and then after that, it doesn't remember anything more about that conversation between the client and the server. That means the client is responsible for tracking its own state, whether through the front-end application state or through storing cookies in the browser or some other way. 3. Uniform interface. Resources that are exposed by the server must have a single URI, or Uniform Resource Identifier. This is done with a directory-like style, as you've seen with the routes that you've created with React Router. 4. Cacheable. Clients can cache responses, and the server responses will contain information about how to cache them or if they should be cached at all. 5. Layered system. There can be many layers between the client and the server. The client will not necessarily know if it's dealing directly with the end server or with an intermediary server that's cached the data that's being requested. Code on demand. This is the only optional constraint. Servers may temporarily extend the functionality of client-side code by transferring executable code, such as JavaScript. So these are the constraints that define a RESTful web service. RESTful web services are built upon the HTTP protocol and will use the HTTP methods, also known as verbs. There are 9 of them: post, get, put, delete, head, connect, options, trace, and catch. The most often used are post, get, put, and delete. These methods are analogous to what's known in database programming as the CRUD operations: create, read, update, and delete. Post is analogous to create, get is analogous to read, put to update, and delete to, well, you know. Of these methods, all but post are considered idempotent methods. Idempotence is a concept in mathematics and computer science that describes when an operation can be performed multiple times, but it will not change what is being operated upon aside from the first time, if at all. As an example, multiplying by 0 is an idempotent operation. If you multiply any number by 0 once, you get 0. If you multiply it again by 0, you still have 0. And you can multiply it again by 0 100 more times, but you'll still have 0. A GET request is idempotent because you can make a GET request of a resource as many times as you want, and it will never change the resource. GET is just reading the resource, it doesn't do anything to it. A put request is idempotent because even if you accidentally send the same put request multiple times, it would just update the same resource with the same change. A delete request is idempotent because if you request to delete a resource and then you request to delete it again, it doesn't do anything more since the resource is already deleted. A post request, however, will not be idempotent because you're creating a new resource every time. So something you should always keep in mind is what operations are idempotent and can be repeated without any consequences, and which ones you have to be more careful not to repeat unnecessarily. A resource on a server is any piece of data that could be requested by a client. It could be a single name from a database. It could be a stock price. It could be a weather report. It could be an image file. It could be an HTML file. Then the resources are made available at unique URIs, and a client can request each resource specifically by its URI. But when the server responds to that request, it does not send the resource. Instead, it sends a representation of the resource. For example, the client might send a GET request for information about a stock from a server's database. That information is stored in that particular database's format. But the server will take that information and encode it into a format that's useful to the client, which cannot read the database format. Most of the time, that encoding will be into JSON or XML format. Then that JSON or XML data is the representation of the resource. And that representation is what actually gets sent in the server's response. Or a client might send a post request to a server, and that request would include in its body a representation of some data in JSON or XML form. The server would take that representation and use it to create a new resource. So the client and the server do not send resources to each other, they send representations of resources, which are then converted to resources. And that's why we call it representational state transfer. Now that you have this basic understanding of REST and HTTP, in the next exercise, you will install an NPM package for a RESTful development web server named JSON Server. And you will continue to update your React app to communicate with that server.